Welcome back. We are starting the final unit of the year, the chemistry unit. Today I believe we are starting with lesson number 32. This is going to be called Inside the Atom. It's going to be giving you a basic idea of what an atom and a molecule and the periodic table are kind of about, just kind of getting a feel for some of the terms. Since you've probably done the electricity unit, protons, neutrons, and electrons are going to be something you're already a little bit comfortable with, so this shouldn't be too hard, especially at the start. This is a fun unit and it's a short unit. I also need to tell you that the new package right here, Chem Pack, you can see right here, Chem Pack for grade 9 science, is available in the office now. You might want to call them. Of course, this is only if you're watching this video during the COVID situation. So you can contact the office to get the packages anytime you want. I've included in the front page a couple periodic tables. And I also said this is the side we're going to use because there's two sides. The back side you don't use as much. You always use the front side. And I put that. I said side we use, side we use. Now what I'm basically doing here is just giving you a couple extra copies of periodic tables because as we go through this unit, you're always going to need your periodic table, and that's the one we use, this one here. So I put it at the front of the book so you can always flip it, you can draw on it, you can mark it up, and if you need another one, you've got another copy on the second page as well. So it's just an extra thing. So today, you should have your Chem Pack, and you should be looking at a set of slides. It's called Inside the Atom. Now I'm going to include this PowerPoint here, or these slides, in the Google Classroom. So you can look at the slides if you want, or you can look at your book. If you can read the booklet, that's fine. So let's just do a little bit here. This is a very quick lesson. We're going to go through it pretty fast. And then there's a video you need to watch of a great science teacher, Mr. Lehan. He does a little stuff, and there's a worksheet you're going to have to do. So let's just get right to it, and we can get you moving. So we're going to talk now about what's inside an atom. Now you know that in an atom there are protons, neutrons, and electrons. And we are going to learn everything we need to know about protons, neutrons, and electrons in this whole unit. Today is just a starting point. We're just getting used to it. All right, so inside the atom, the subatomic particles. The terms. Atoms are the smallest particle of an element that still behaves like an element. What does that mean? You could have a piece of gold, of pure gold. But within that lump of gold, there are thousands and millions and billions of gold atoms, and they're all the same. They all act the same. So an atom is the smallest form of matter, right? So the smallest particle of an element that still acts like that element is considered an atom. An element is a pure form of a substance, only made out of one kind of atom. Now, most things in the world, if you look at your periodic table here, most of these, like hydrogen, lithium, beryllium, copper, things like that, they don't normally exist in nature in pure forms. Copper can be mixed with nickel and zinc, for example, or things like that. So you have to purify them using their density. You heat them and you melt them and you make them pure. But if you get a pure chunk of it, you would have an element, a pure form of a substance, only made out of one kind of atom, but it could be millions of atoms, right? Depending on how big it is, right? Can be made of many atoms. All right, let's move on. Mass. Now this is cool. I'm going to give you a little bit of a head start here. We're not going to get into this just yet, but take a look. If you have an atom, as you know, in the middle, you have the protons and then neutrons. And all around, in rings actually, kind of flowing around, is where you're going to find the electrons. Just so you know that in general, right? That's kind of what an atom looks like. In the middle of an atom, if you zoomed into it, you'd have protons and the neutrons in the middle, and they would take up almost no space, but all the mass. And electrons take up all space, all the space, but no mass. Now, you don't need to write that down. You can if you'd like to. But what does that mean? What I'm telling you is that in this middle area, if you were really looking at it, this is what it would really look like if you zoomed it in. You'd have this huge area of electrons, and then the nucleus would just be that big. It would be tiny. I'm drawing this so it's a little bit clearer to see. But what you need to know is that almost all of the mass of the atom is in the nucleus, in the middle. So the only thing that has weight, or mass is the proper term, are the protons and the neutrons. Protons and neutrons have mass, and they're in the middle, and they're tight together. They take up almost none of the space, yet they weigh everything. That is kind of weird, but it's kind of cool. But you need to know, protons and the neutrons are in the middle there, and then everywhere else, there's little electrons that take up all the space because they're flying around in orbits or rings or patterns, depending on what level of physics you're studying. And they have no weight, but they take up all the space, which is kind of cool. So let's look at this slide because I kind of explained it before I read it here. Protons and neutrons weigh much more than electrons. Protons weigh about 1,836 times more than an electron, and a neutron weighs about 1,837 times more than an electron. So an electron is like very small compared to these, right? Electrons take up about 99% of the space of atoms as they move in shells. And man, these shells and energy levels and rings that electrons flow in outside the atom in these rings, we're going to be learning about that, and it is cool and fun, and students always love drawing the shells and the rings and stuff like that. It's a cool assignment. You'll be doing it very soon. Let's move on. Electric charges, well, you know this. There are positive and negative charges. All atoms are neutral naturally. That means they have the same number of protons and electrons. So we know, right? We know that protons are positive, electrons are negative, and neutrons have no charge, right? We also know heavy, light. We can also say, this is just to organize concepts, right? Small, lots of space. That's kind of putting everything kind of in one thing. But now let's think about this. That means that the nucleus of an atom is the heaviest part. And every element, if an element naturally, we're talking naturally, not if we altered it or put it through reactions, but if an element has 5 electrons, how many protons does it need to have? It has to have 5. It always balances. Protons always equal electrons. For neutrons, how many? It depends. We can figure that out later. So that's the variable. But if there's 5 protons or 5 electrons, protons and electrons always equal each other to make it neutral. Because if it wasn't neutral naturally, it would be reacting all of the time. Electrons have a negative charge and exist in shells or rings around the nucleus or the atom. And atoms can become charged positively or negatively by reacting. And don't worry, we're going to get into atoms reacting and creating positive and negative charges. We'll be doing that a little bit later. There's that note there that I was working on. All right, now we talk about the mass. Almost all of the mass of the atom is in the nucleus. We know that. Protons and neutrons weigh much more than electrons. Oh, we've talked about this. We already did that. I pressed the wrong button. The nucleus. The nucleus of an atom is a tiny region in the center of an atom. It contains all the protons and neutrons, or the mass. This is where almost all of the weight of an atom is. The nucleus has a positive charge. That's important. You want to know that. Nucleus is always going to be positive, whereas the outer shells are going to be the negative areas of an element. Protons and neutrons are almost impossible to remove. So if you got that atom or element, the protons and neutrons, and then you got your electrons here floating around, that is almost impossible to separate. This area is very positive. This area out here is very negative, and you can't split that nucleus. You can't separate it, because if you do, you create a nuclear reaction, which can be used for energy and things like that, but it's a very complicated process. Anything else here? Nope, that's it. So that's it for these slides. Now you're going to learn a little bit, because the next lesson is weird. The next lesson, we talk about the history of how did we learn all this stuff? What did people think 100 years ago, 200 years ago, 1,000 years ago? What did they think? And then what did they learn? And how did they get proven wrong? And then how did they adapt? And that's the next lesson. So what we're going to do is we're going to go to this video here. Grade 9, Mr. Lehan teaches you stuff, the history of the atomic theory, and he's going to give you a good 12-minute background on what people believed atoms were over the different courses of history, because it's important as a scientist to learn where ideas come from, how ideas were tested, how you could be proven wrong and adapt over time. What you're going to learn, the Greeks weren't right, but it's cool to understand what they know, because that way you can learn by mistake and how science evolves. Science is always changing. We're always learning more. It's fascinating. So you're going to watch this video, and it's included in the lesson or the assignment in the Google Classroom. I put this video here, Mr. Lehan, and then your job is to work on this assignment right here. Mr. Lehan teaches you stuff, so you're just going to do these questions right there, 1 to 5. Let's see if I can find these in the booklet for you, because that's what you're going to be doing. Let's see, right there. That's the sheet you're going to do. And your job is to submit pictures of your answers and to send them to me. And then we're going to move on to a real thorough history of the ideas about atoms and how people discovered more and more and more until we get to what we know today. So take care, and we'll see you soon.